This
contribute.
conference will now be recorded.
I apologize. I missed starting the recording.
Okay. Should I take it again? Maybe not. But yes, as said in this slide, I just tried to summarize very shortly what will be the key content of that regional summit presentation, including those technology enhancements like new generation of Intel Xeon scalable processor and those improvements what that brings, like DDR5, PCI Gen 5, and of course presentation includes high-level block diagram, and then about 2U server, what that 2U server variant what we did not have in previous generation will bring for our use cases and also to some or other cloud and edge use cases like higher computing performance in single compute, which then brings better energy efficiency, density, and in some cases better balance between general purpose GPU and then needed accelerators for application. And other key content of presentation will be one slider about the Cloud Run use case and what benefits new server will bring there, including performance chart showing improvements in performance based on 2U server and new technology, and then few slides about mechanical design and modularity and toolless design, what will be of course natural for open compute project designs, and then slides that summarize 1U and 2U servers led interfaces and key features. So this will be the content of coming summit presentation in very short way, and then about the planned contribution. We have a plan to contribute server design as OCP inspired, giving specification. This will happen together with ASUS during this year. So that was the first presentation I have. Any questions related to that?
Yeah, a question on the accelerator piece. So I'm assuming you're talking things like GPU cards and things like that. Is that what you're talking about there?
It can be GPU cards, or it can be Cloud Run SmartNIC like accelerators, what are crucial in cloudified VDU designs, but basically any add-on card having significant high power, because we continue to have very efficient cooling in system, so we can cool 300 watt full height, full length, double width card, or we can cool 3 times 75 or even higher half length cards in this design. So it enables basically any kind of accelerator to be used. Design.
So theoretically, it could accommodate these new, much larger GPUs and things like that.
That's true, and that's target, and we discussed about those GPU accelerators in last call, and of course it's not so sure that in far edge you need to have that kind of very high power accelerators, but there are use cases where you need to have GPU accelerators, and this server is designed to support that.
Great.
And what is not, of course, in that summary, but all PCI slots will have 516 connectivity, and there is no that kind of limitations what might have been case in some earlier designs, and of course that is something that comes partially from that new Xeon features that have more PCI lanes, and it enables that kind of design.
And so, like, could you accommodate both, say, the like level 1 accelerator and a GPU? Like how many things can we put in here?
There are 3 PCI slots, so it really depends what is the form factor of each card. And so if you have that kind of double wide card, you can have third card for other acceleration use case, or NIC card, or any card. And then of course we have that OCP version 3 NIC slot here in the bottom. So actually 4 add-in card can be hosted by that server. But details of those cooling capacities and things like that are then shown in presentation in Summit.
Okay. But like from a cooling and power budget, it's been kind of designed to be able to kind of handle this.
That's true, and actually we already last year we kind of saw white paper what are the targets, and power level of that kind of 2U server is more than 700 watts, and it of course depends what is the power of CPU socket, what is then left for accelerators, and of course what is the storage. What I did not mention it was that we have actually 6 times E1S slots here, so it gives quite good amount of storage also for this kind of edge compute. So it's not limited to only accelerator and high performance edge server, but it also can be like a storage server, of course in that limitation that we have 6 E1S slots, and then additional storage can of course hosted by PCIe cards, like we have had in some cases in earlier server generation.
That's great. So you could basically do some large big data things in here as well.
Yes, idea is create very flexible design that can be used for compute and then for accelerator, hosting accelerators, or even storage without changing server design. And of course what I don't have in this page, of course we continue to have one use LED. It's basically just cutting it from here, so you have 1 PCI slot, 2 storage base, 1 OCP card slot, so it's kind of half of this 2U design.
Okay.
And of course using same motherboard and same software, and everything is common.
Nice.
Guys, can I ask one question, Maciek from DCX here. John, I was asking you probably 2 weeks ago about some details regarding the chassis, the Edge Open Edge chassis, and thank you for coming back to me. I could not participate in that call, but I have just one question right now. With those new Intel processors and those GPUs, the power feed capacity of the current Open Edge chassis was, I think, 700 watts for 2U LED. And you mentioned that there will be bigger power requirements from that new updated 2U chassis. So my question is basically what we can expect on the, let's say, typical edge installation. I mean, in terms of the maximum power capacity of the open edge chassis, using those new servers.
Yeah, we always talk about maximum powers, and I think that is very relevant question to talk about what is typical and what we expect. Of course, we don't expect that all servers will be hosting highest power accelerators, and actually in our key use case where I actually have other presentation, we see that there will be in this kind of 2U server, the configuration will have OCP NIC, not that high power, 2 to 3 times Cloud Run Smart NIC, about 75 watts each, and 185 watt CPU. And we have some measured data, but it's far less than that 700, 800 what can be get from chassis. Those original chassis values actually were more kind of just limiting total power of chassis to that power capacity of PSUs what we selected originally, and actually from the beginning chassis can host higher power single sleds, but then of course you need to balance it so that you don't exceed that 2 kilowatt PSU limitation, or if you are using 1.2 kilowatt PSU, what is one alternative in that form factor, then you should not exceed that. So I think I saw that in one white paper that there are certain rules how you can have higher power servers in system if you can reduce amount of servers or use lower power servers in addition of that higher power server. And in practice, as I said, we don't see that very typical to have something like 700 plus watt servers in far edge. We more see that it will continue to be 400 watt level or so.
Thank you.
So is this Ice Lake or some other variant?
This is fourth generation. I don't know. Is it still allowed to say, but it's Sapphire Rapids generation of CPU. But official name is the fourth generation Xeon scalable processor. Okay.
What would you be looking for specifically in Ice Lake?
Sorry.
What would you need specifically from Ice Lake? Or is it just a question?
Ice Lake was in our previous generation or current generation, what we are of course still delivering. So
basically takes it to the next stepping.
Yes,
of the processor family.
That's correct. But maybe I jump to second one. So this one is 10. Okay, going those architectural options for Cloud Run VDU. And this is again only short summary of topics what will be then covered in presentation in summit. And again abstract. So okay. So it's just telling that the we will cover in presentation different deployment options of virtualized distributed unit VDU, and then also discuss about that how open edge hardware can flexibly support key acceleration technology alternatives for L1 processing. And in this presentation, I picked one drawing from final presentation showing those cloud radio access network, what it looks like, and what are the key components of that. So there are radio units, those units what you can see from masts, and those are connected to the user equipments. Then there will be those those virtualized distributed units. What is the key content of this presentation? And there is processing of hard real-time baseband functions, and then virtualized central units, VCUs, which are processing non-real-time baseband functions. And then presentation also covers different deployment options of Cloud Run, showing how you can locate those VDUs and VCUs. Those can be closer to the radio unit, or those can be further away from those in certain limitations. And maybe the key topic is then that VDU L1 acceleration, what is then analyzed in regional summit presentation quite thoroughly. This is only summarizing those two key alternative technologies which are used for 5G physical layer acceleration to reduce load of CPU, what is not so optimal for that kind of processing. And there are those two alternatives like look-aside architecture, where only part of L1 functions are accelerated, like LDPC forward error correction, and majority of L1 is still done in CPU, like you can see uppermost drawing. Then other alternative technology is use inline accelerator for entire L1 layer using that kind of run SmartNIC card, and then you don't have any more L1 workload in CPU. You have only L2, L3 workload here, and it frees capacity of CPU, or you can use smaller core count in CPU or do more capacity with same CPU. And then the final presentation will summarize key KPIs like energy efficiency, TCO, architectural flexibility, and things like that. So there will be analysis of those both alternatives and what kind of use cases are better for each of those, or when each of those are more applicable. So I can say that this presentation will be quite interesting if you want to learn more about cloudified radio access network and L1 acceleration. It will be having a lot of good information. Any questions about this topic?
What's the target availability for this new generation of hardware?
I don't even have exact timelines. We have hardware in labs that I can maybe say, and there will be very soon possibility to get some hardware for POCs, but I don't have in my memory cannot find exact date when those will be released.
Okay.
For wider use.
And is the management, is it the same, basically the same as the previous generation in terms of like managing it from the hardware perspective?
I'm not sure that I fully got your question. Management, what part of management you mean?
Like, being able to kind of, configure it, BIOS settings, it's just the lower level things.
Yes, those lower level things are pretty similar in server level, like earlier generations of servers, and same upper layers will be used for managing and collecting information. And if the question was about server, the server availability, this is basically available, maybe not now, but in a couple of months. Then about the acceleration topic, it's kind of coming a bit later than server hardware.
But you said that there may be some possibility to do some POC work with it earlier.
Yeah, it's basically very soon possible.
Okay.
Do you know if this is intended to deal with CPRI as well as eCPRI, or is it just eCPRI on the radio interface?
Yes, this around smart NICs will be capable for both. And if I go a little bit back, of course, one additional, let's say, flexibility enabler is that front hall gateway, what you can see in this picture. This is device that can convert from CPRI to eCPRI, but this is not mandatorily needed, but it can also aggregate lanes, links, so you can reduce amount of connectivity needed between radio units and video servers, and that kind of flexible options will be there and are available from Nokia.
And that front hall gateway, is that a sled for the server? I mean, for the chassis?
Sorry again, I think I have some audio issue, but I did not fully hear what you said, Greg.
I'm sorry, I was just saying, was the front hall gateway is a sled form factor in a open edge chassis, correct?
That's correct, yes. It's LED form factor, and it can be hosted by same chassis like servers.
But it doesn't require another piece of hardware there.
No, it's you just need one free sled place from chassis. Then you can add front haul gateway there. Nothing more needed. So same PSUs will then power front haul gateway that are powering servers, and same management. RMC can collect management Ethernet from front haul gateway, so it's fully compatible with same chassis and other components in OpenEdge, and it can act like a Ethernet switch. So you can use that as a Ethernet switch. If you have eCPR connectivity only, you can also in that case reduce amount of needed connectivity by using front haul gateway.
Here I have some question. If you go to the next slide, because in your local side, inline part, and if you look at the radio, and then there's if I remember correctly, there's no backplane. So here for your smart NIC or inline acceleration card, do they have to use some ports to connect it to your server slot in order to offload? So basically, one in and one out will consume you two. If you have 2 server slots in your chassis, how are you going to handle this demand?
Okay, again, I'm not sure did I hear.
No problem. Yeah, I will try to talk loud. But basically, to summarize my question, I remember there's no backplane for OpenNet chassis. So that means for your smart NIC or for the inline, that means you have to get one import and one output in order to offload from the CPU on the server. So if you have more than one server slice in your OpenNet chassis, how are you going to handle this type of offloading?
Actually, those run smart NICs are similar like standard NIC card. So those will be located in PCI slots of each server. And in case you need more than one server in chassis, you then have a needed amount of Cloud Run smart NICs in all of those servers, and of course those can be different amount in different servers. And then it can be either directly connected to the radios, or it can be using switch at front haul, like using that front haul gateway, or in eCPRI case it can be Ethernet switches. Of course, time-sensitive switches are needed, but it can be implemented many ways at front haul. It's actually quite complex topic, and some more details are for sure in that presentation what you can see in Summit.
Okay, I will wait. Just a very quick spec for your NIC cards, smart NIC cards. How many external ports does they have?
Yeah, I think that it's a bit tricky question. We have physically two QSFDD connectors there, and actually it depends. Is that in case of eCPRI, it's a bit higher lane count available, and with CPRI it's a bit lesser. But I think that this connectivity is quite well handled already with that smart NIC, and then if in case that you have very, let's say, big amount of FDD radios. As an example, you can increase that connectivity easily with front hall gateway.
Okay, sure. Thank you. I will wait for your presentation in the regional summit. Thank you.
Thank you.
Oh yeah, since you're talking about the Cloud RAN part, actually, well, recently I came across one architecture for 4G or LTE is called the LIPA, the local IP access, in which the e-gateway, the eNode B and the P gateway will be integrated together for some local access. So in that case, have you ever thought about some architecture to handle like a LIPA, those type of integrated architecture? Not just the VDU, VCU part, it also includes the P gateway. It's called the LIPA. It's a local IP access for 4G or LTE architecture. So normally we have a eNode B and P gateway separated, but for the LIPA actually is integrated architecture.
Yeah, I think that this goes a bit away from my expertise area because I'm pretty much
sure.
hardware engineer. So, but what I can say that of course, especially in case of that smart NIC is in use, there can be easily make system where you have a lot of free cores for any other application. So it's possible, and technically possible, in my opinion, to have other applications running into same servers.
Sure.
It's maybe not that easy with that Lucasite kind of architecture because there you need more cores and there are more real-time applications running in CPU. So it's more demanding in CPU point of view and maybe harder to have other applications running. Of course, I believe that also this is possible.
Okay, sure. Thank you.
Okay, maybe that covers my part, and as said, Lucas Ferreira still have one presentation.
Yes, thank you, Samuli. Can I be the presenter, John?
Yes. Let me see. Okay, Lucas, you should have presenter rights now.
Okay, can you see my screen then?
Yes, we see it.
Perfect. Let me just try to collapse this. Okay, so and the topic of this presentation is to continue to present something about the Open Edge, but mainly the idea of exploring direct liquid cooling for those Open Edge servers, and mainly presenting viability study that we have conducted in looking into how those kind of Open Edge servers could be converted to direct liquid cooling. The main abstracted is to present this kind of viability study using the cold plates coupled with pumped liquid cooling for the Open Edge and cooling the CPU. This viability study in which we are looking into the analysis of the required design modifications to the server sled and to the chassis. And the results obtained from this study we presented are showing the potential to further improve the capacity of the servers and increase its energy efficiency. So it becomes a possible way for, Let me see something. Okay. Nope. Try to collapse here this screen. Yes. So basically, the results of this study, we aim to show the potential to further increase the capacity of the server, improve the capacity of the servers, and increase its energy efficiency, and being a possible configuration for challenging far edge scenarios. And one of the main our main objectives as well with this presentation is to foster the collaboration in developing specifications of advanced cooling solutions for the OpenEdge platform. Not only what we studied here in the viability study, but look into how to improve the cooling and energy efficiency of this OpenEdge platform. So basically, in a nutshell, some teaser of what's going to be presented at the regional summit there. Basically, we'll talk a little bit about the OpenEdge cooling, how it's currently being done. This is the 1U server that's shown there, and this OpenEdge cooling is optimized for high performance edge computing, and it's currently being tested and being designed to operate in temperatures on the range from -5 to up to 55 degrees. And it's basically using the traditional air-cooled designs. The fans are located in the sled, and then each sled carries its own fans, and there is different kind of fans for the 1U and the 2U designs. And basically, this traditional system works, and its efficiency for the OpenEdge, and especially this new generation that Savoli presented, is being now approved for these kind of temperature ranges. But the idea of this viability study is to investigate how what could be the potential of these kind of OpenEdge servers to be converted to another advanced cooling solutions, including the pumped liquid cooling that we studied here. So basically, this kind of viability study, we designed this proof of concept in which one of the fans is replaced by modules for the connection of the liquid, and the heat sinks replaced by a cold plate. And basically, our main objective here is to use an evolutive approach, meaning that this kind of liquid cooled will be fully compatible system between the liquid cooled chassis and air cooled chassis. So basically, you could replace a liquid cooled chassis into a air cooled server there. And also, we are continuing to use a mixed cooling approach. So we are mainly cooling the CPUs with liquid cooling in this proof of concept. And the rest of the components on the server sled are being cooled by the fans using air cooling. And then from this proof of concept, there will be some of pictures and designs, and also the physical object will be presented at our booth there in the regional summit. But some of the initial results that can be shared here, mainly that this solution was proven to be reliable, operating in more than 200 hours during testings, and we didn't have any kind of mechanical failures or leaks or any kind of problem like that. And we are able to achieve high cooling capacity with low thermal resistance and low pumping power requirement. This also contributes to having a good energy efficiency. We achieved high thermal stability with the CPU keeping a constant temperature even at high ambient temperatures. And low fan duty, since the lower fan duty, since the cold plates, the CPUs are the components that require most cooling. And also by using the cold plates and cooling the CPU, we are helping to cool the board itself, and this helps to cool other components cool, as the VRMs and also the DIMMs that are next to the CPU are kept at a lower temperature, since with the use of the cold plates, that this whole region is kept at a lower temperature. And this allows us to operate with lower power fan duties or with lower fan speeds, and this allows us to measure some reduced stout noise levels. And this graph shows one comparison in which we are using 270 watts power CPUs. These are high power CPUs that are not commonly used for this kind of 1U server. And here we have the full chassis populated with 5 servers. And in the first column there, we have those 5 servers being idle. Then the temperature of the server CPU is totally dominated by temperature of the liquid. We are pumping their liquid at a temperature of about 25 degrees. And when we stress the CPUs, the CPUs are being heated a little bit, but then they are kept at a constant 50 degrees temperature, no matter the ambient temperature, even if you go up to 50 degrees there, and we are keeping the CPUs at the same temperature without any modification for the or any additional control of the amount of liquid being pumped. So the temperature is showing that we have low thermal resistance there that we are able to keep this kind of low temperature. And basically this viability study shows the potential of this use of this kind of configurations. And this is something that we are still looking into and analyzing the results that come from this POC. Basically, I prepared something quite short here for this so that we don't do so much time here today, but now we can discuss some questions and also, yeah.
So when you did the testing, was that like the sled in the chassis and then looking at the temperature, or like what was the configuration for when you did this kind of thermal testing?
Yeah, we have a chassis that is converted to have the manifolds and the connectors for the liquid cooling. The pictures and also this chassis would be present at the original summit. And then the server is populated with 5 servers. Those servers are modified with cold plates and connections for the liquid cooling. And then this whole system is mounted inside a thermal chamber so that we can test what would be the performance at different temperatures here.
Okay. So this should also help with the life expectancy of the hardware then as well, I would assume, especially if you're going to run it hot quite a bit.
Yeah, this is something that we can investigate still. I'm sorry.
Yeah, because I guess what you're saying is you were able to kind of keep it at a constant temperature even when it was at the stress level there. So, you know, if things are running hot, you know, it doesn't mess it will potentially improve your the life expectancy of things as well, I guess.
Yeah, but sorry, that just to, if we have to also consider the life expectancy of the liquid cooling components and of the fluid itself, and this is something that that's why I'm not saying for sure that it's going to improve the life expectancy of the server, but we have to look into that in the long term.
Well, that's interesting. So, like, is there like a maintenance piece then that would have to be done with like this the liquid part of the liquid cooling?
It's a closed loop, and so there shouldn't be any additional maintenance for the IT fluid there, the liquid that's being pumped there. And those connections, they show that they are quite reliable during our testings, but I can not answer for that for longer periods of time. That's something that we should still investigate.
Okay.
Lucas, I have one question, Magic from DCX here. The question is about the condensation control. So you're introducing another solution, I mean, very effective cooling solution, which is direct tube cooling, which is awesome. The question is, but it's relatively easy when we are in the white space, so we can have the proper CDU, when we have lots of automation, just to get the proper temperature, so we'll not get into the dew point. So what's your solution on that in the kind of edge application?
Yeah, in terms of energy efficiency, also this kind of relates that we are more looking into warm water cooling, not so much into cold water cooling. So basically, we have better efficiency if you're pumping water at a little bit higher temperature. For example, if the liquid's being kept at 40 degrees, then everything's being controlled, and we do not reach CPU temperature above 60 degrees, so it's still quite cool, overcooled yet. And then we have a lot of possibility for example, using free cooling if we are using warm liquid cooling, and also we don't run into the possibility of condensation there.
Yeah, I was mainly concerned about overcooling the system. So we have let's say relatively well, we have closed loop. And what would happen if we will basically overcool if we cannot get the if you would not get the coolant warm enough to avoid going to the dew point.
Mm.
Maybe just one final question. What about the immersion cooling? The another technology when you can be fully isolated from the from anything which is airborne and basically have everything in enclosed closed solution fully immersed with the electric coolant. Did you went into the are you thinking it's a viable solution for Nokia?
My personal opinion is that we should look into that, and we have some ideas that this OpenEdge could be a platform that could be feasible to be converted to immersion cooling, but we have not yet started this kind of study.
Yeah, and as Lucas said, this is study phase, and there will be other options what we will study, but in this phase, I think that we will share more information about what we have done with OpenEdge, with this liquid cooling, and with this approach. Of course, we are eager to get more ideas and more good innovations what we then can together build for future of edge solutions. I think that it's not final one even what we are now doing, and maybe it's not looking like what we have prototyping now when final products are coming. So it's still open topic for us.
Awesome, thank you.
Does anyone else have any questions?
I'm just curious about the liquid you're going to put. So it seems you have to pump into to the server slide from some outside place, right? So it's how I'm going to handle that.
I'm sorry, I don't think I quite got
like
your question.
For the liquid cooling, you have to pump into the server slide some liquid from somewhere. Yeah, so it has to be like a closed loop from some container outside of your server. How are you going to handle that part? Just curious.
Yeah, we can have a thermal radiator on the outside of the system, and then basically, for example, one configuration would be that we have an external system that is rejecting the heat to the environment, so that we can maybe use a possibility of using free cooling there. And then we are only expanding, instead of having those powerful fans there, we could expand a little bit less power in the system, but also be less dependent on the cooling of the environment itself. So the system as a whole, we reduce the dependency on the cooling of the site.
Okay, sure. Thank you.
You know, you guys, Nokia, you could benefit from some free R&D. That's we have the cooling solutions group at OCP are pretty advanced, and in fact, there was a study done of where a lot of people get their information, and ASHRAE came in second to OCP. So I would suggest when it comes to types of coolants and cycles and loops, you guys at least consult with them a little bit and see maybe if there's some helpful things that they can add to your design.
That's a good suggestion, Bijan.
Hey, Bijan, I think that Lucas is involved in the cooling technologies group, has been for quite some time.
Yeah, we have been following what's been happening there and trying to adapt some of what's been developed to OpenEdge as well. But still, as Samuel mentioned, this is kind of a preliminary study that we are presenting and trying to gather some interest from the community into this kind of advanced cooling solutions here.
Yeah, no, I think, yeah, so my point of view is that this is essential based on kind of the ramp of development of components, right? So thermal density is increasing. So yeah, I think this is the right way. I think you guys are on the right path. And like I said, my recommendation is only as you go forward in your exploration to see what the cooling group can add, if anything, that can help you out. There's a lot of stuff going on there. Like they're looking in there's some good work going on in blind mate connectors for cooling, and there's all kind of aspects.
Yeah, I agree. It's quite interesting what's been happening there, and I'm actively following there.
Is there any implications for this from? I assume this is using some sort of water cooling as opposed to like one of the now supposedly discontinued 3M immersion cooling liquids.
Yeah, this is we are basically using a mixture of distilled water with some glycol for anti-freezing and also some anti-corrosive solutions there. But basically one kind of common liquid for cooling, but based on water.
Is anybody looking at cooling solutions for the edge environments that supply that fluid or that water locally? Is that part of the rack team or the rack, the mechanical or the racking part of the OCP? Do you know?
Oh, OCP has a recommendation. They've written a couple of specifications on coolants. That's published. So you can see the recommended coolants for single phase and dual phase, two phase types of coolants. They've already kind of adopted the 3M stance and removed the PFAS types out of their recommendations. So yeah, and then there's a third type of organic. So if you really want to go sustainable, then you can also look into organic coolant.
Yeah, that's a really interesting area of development, and all the different kinds of things that are liquids that could be used to cool these environments.
Although a CEO of a data center operating company told me that it smells like pancakes when he walks into his data centers, and it's coolant.
Is that bad?
But that's not a bad thing.
Personally, I prefer waffles.
Either way, it could be worse.
Okay, any other questions or comments?
The PCIe connectors, those are the M2 and PCIe. There's connectors there, but is there room for full-size cards, half-height cards? I might have missed it. I'm sorry.
What I'm showing here is the 1U. So this is a half-height card only.
Gotcha.
Solution, but the 2U solution that Samuel presented before that can support the double height.
Okay. Yeah, because one thing you'll need is synchronization. So it needs to be a time card kind of solution.
Yes, that's a crucial part in that Cloud Run solution, and in our Cloud Run Smart NIC there will be synchronization taken into account fully, and also in that front hall gateway product we have very let's say accurate synchronization capabilities. So it's crucial, as you said.
Yep.
Any other comments or questions?
This is great. You guys are going to show this at the regional, correct?
Yes.
Yes, that's correct. Lucas, please continue.
No, please, you can go.
Yeah, we will have a kind of not functioning but full chassis with 5 one-use LEDs with this cooling approach, so we can show that prototype or POC what we have done for this testing purposes. And one comment related to that we cannot cool 270 watt CPUs in 1U service LED, so it's with air cooling, and here we had 270 watt CPUs and all fully loaded, so it was totally kind of much higher power computing system than what we can do with air cooling. So it's that kind of impressive result, even with that higher power and higher performance. We were much lower in CPU temperatures. So it really enables, liquid cooling really enables much more powerful compute if needed. And of course, related to that same topic is that there are and there will be, for example, GPU accelerators with liquid cooling available, like a COTS products. So
Nice.
there are a lot of topics happen in this area.
Very nice.
Yeah, very nice work. Thank you.
Anything else? All right. Well, I see we're over time here, so if nobody else has any questions or comments, I appreciate everybody's input, and thank you, Samuli and Lucas. Very interesting topic, and I guess we'll pick up next time, and we'll kind of talk more about kind of this GPUs at the edge and kind of what we started last time, and then of course any other topics everybody wants to bring up, please feel free to share them, and I will add them to our agenda.
Okay, thank you guys it was a good presentation.
Yes, thank you very much. All right, we'll see you all next time.
Thanks, everybody. Have a good evening or day.
Bye-bye.
Thanks so much.
Thank you. Bye-bye.
Thanks all.